Hello, everyone. Welcome to the workshop, Supercharge your web app using the modular Firebase JS SDK. My name is Feiyang Chen. I'm a software engineer on Firebase. I'm one of the maintainers of the Firebase JS SDK for the past 2.5 years. If you have used our SDK before, you probably have noticed that our SDK is pretty big. And by using our SDK, your app becomes really big. To give you a concrete example, to use sign in with email and password from Firebase Auth, which is a common use case, you will include 246 kilobytes of code from Firebase. It's not a small size for a web app. So is the implementation of signing with email and password that big? No, it's not. So why do you have to include this much code in your app? That's because our packages are monolithic, meaning to use anything from our package, you have to include everything from the package to your code to use sign in with email and password, including things you don't need, like sign in with Google, sign in with Facebook, Cordova support, React Native support. You don't need any of those features, but you have to include them in order to use just sign in with email and password. And that's not good for you because that makes your site load slower than necessary. And people could abandon your site if your site is too slow. And the ranking of your site could be negatively affected if the site is too slow. And we understand it's a big pain point for a lot of developers. So we want to address the problem for you. So we rewrote the SDK. The version 9 of the Firebase JS SDK is finally tree shakeable and modular. You import only what you use and include only what you import in your app. So in this workshop, we're going to migrate an existing web app made with the version 8 of the Firebase JS SDK to version 9. And we're going to gradually reduce the bundle size by migrating to the modular API package by package. At the end of this workshop, we're going to have a web app that's drastically smaller than the original one with the same functionalities. And to do this workshop with me today, you will need a modern browser. I will be using Chrome, but any modern browser should work. And you need an IDE. I'll be using Visual Studio Code. You also need to have npm installed on your machine to install libraries to build the app. And we also have a live Q&A session for this workshop. So feel free to post your questions there during and after the workshop. Our TAs will try their best to answer your questions. So with that, let's get started with the workshop. As the first step, let's get this project set up first. Our code resides on GitHub, so let's copy the code from GitHub using the git clone command. Let's open the code lab here. And on the step 2 of the code lab, you should see a snippet with git clone command. So let's copy the command here. And we're going to go to our terminal here and copy the command here to download the code. And once we download the code, let's open it in the IDE. And we'll open Colab here. All right. So before we build the app, we need to install the dependencies. And we will do that in the terminal. Let's go back to the terminal. And let's cd into the project. And run the command npm install. It's going to take a while to finish. Depending on the network speed and your machine, it might take different time for you. I'm going to wait another 10 seconds so everybody has a chance to finish. All right, let's try to build the app. And to do that, we will run the command npm run build. So in the same terminal, let's put the command run npm run build. And the last thing we need to do is to start a local web server so we can play with our app in the browser. I'm going to do that in the second terminal. We will need the first terminal to rerun the build command whenever we make a change. So I'm going to do that in the second terminal. All right, so I recommend everybody have two terminals open, one running the server and one to run the rebuild command whenever we make a change. So in the second terminal, I'm going to run the command npm run serve. And we need to cd to the project first. And run the command npm run serve. And once the server starts, you will see a URL on your console. Let's copy that URL and open the URL into the browser. This is our sample app. It's a very simple stock watchlist app. And hold just 1 second. Let me set up this little thing so we get real-time updates. There we go. So this is a very simple stock watchlist app. On the homepage, before you log in, we have a list of popular stocks and their prices being streamed in real time. You can log into your favorite. You can log into your personal watch list here. And we're using anonymous login, so you don't have to input any personal data to log into this sample app. And in your personal watch list, you can search and add your favorite stocks to the watch list. So I'm just going to add a couple of random stocks to my personal watch list. And keep in mind, this is a sample app, so we don't have all the stocks in the world. So you may not be able to search and find your favorite stocks. And also keep in mind that we are using historical data from the past for the price. As you can see from the last column here, the price data are coming from 2019. So please don't make any investment decision based on the data you see in this app. Now, we have the baseline app up and running. Let's check its size. And to do that, we're going to open the Chrome DevTool. And to do that, let's right-click anywhere on the page and click on the Inspect. And we're going to the Network tab. And please check the Disable Cache checkbox. It's already checked for me, but if it's not checked for you, check that checkbox. It makes sure that every time we refresh the page, we always get the latest change. And let's also move to the end of the row. There's a little icon here. So click on this, and there will be a checkbox that says Use Large Request Rows. So also check that checkbox. it's going to give us more information in the table below that we're going to look at. Now we have everything set up. Let's check the size of the app. So now we don't have anything here. That's because we opened the Chrome DevTool after the page is loaded. So let's refresh the page to capture the trace. And we are interested in a file named main.js, and that's our app. So find main.js in this Chrome DevTool network table. And we're going to move over to the size column here. Now, there are two numbers here, a small one and a large one. The small one is the compressed size, the gzipped size of our app. And the large one is the original size of our app. Let's remember the two numbers because we're going to compare with them as we progress in this workshop. And I'm going to put them down into a Google Doc that I prepared so we can remember the two numbers. So 138 and 446. So I'm going to open my Google Doc and put a number here. So this is the original app, 138 and 446. All right. Now we have the app up and running, which is implemented with the version 8 of the Firebase library. Let's go ahead and update Firebase library to version 9 to start the upgrade process. Open package.json. Now you can see that we are using the Firebase library version 8. Let's change the version to version 9. We're using the version 9.0.0-beta 2. And since we changed the version of the library, we need to reinstall the libraries to get the new version of the library. So we are moving back to the terminal and run the npm install command again. I'm going to wait another 5 seconds so everybody has a chance to finish. Cool. Let's try to rebuild the app to see if we can still build the app successfully after the upgrade. So unfortunately, it failed. And there's error from the file firebase.ts. So let's go to that file and see what's going on there. Switch back to the IDE and open the folder source and open the file firebase.ts. There we go. And the error says the module has no default export. And that's because in version 9, the packages export individual functions using named export instead of a single Firebase object that contains the entire API, like what we see on the screen with the version 8 library. So that means in version 9, we are able to pick and import the only things that we use in our app, and the ones we don't import will not be included in our app, making the app smaller. Now, it sounds like a lot of work to upgrade because the API is totally different. So that means we have to basically change everything that interacts with Firebase. Well, it is true that we will end up updating a lot of code, but we don't have to change everything at once. Version 9 comes with the set of compatibility packages that has the exact same API as version 8. So we can use these compatibility packages to upgrade to version 9 without changing a single line of code. Then we can upgrade to the modular API gradually, package by package, to take advantage of tree shaking. So as the first step, we're going to use the compat packages to make our app compile and function again first. So it's pretty simple. We just change the import path to point to the compat package, like so. And we're going to do the same for all the packages. Now, the error went away. We are ready to rebuild the app. npm run build. Now, let's go to the browser to refresh the app to make sure everything still works. And remember that we click the disable cache checkbox here. So when we refresh, we are getting the latest change we just made. So let's do the manual integration test to make sure nothing breaks. Just going to delete something, add some random stocks back. Cool, everything still works. So the compat packages are great. If your site uses a lot of Firebase services, or you have written a lot of Firebase-related code, compat packages provides an easy way to get started with the upgrade process. But keep in mind, compat packages are not tree shakeable. So you're still including unused code in your app. And to tree shake them, you will want to eventually to migrate to the modular API. As I mentioned before, we don't have to change everything in one shot. We can upgrade one package at a time and tree shake unused code from the packages that we have upgraded. And when I say package, I mean in the code we see here, right? We're using Firebase app, that's a package. Firebase Auth is a package. Firebase Firestore is a package. Oops, let's go back. I just accidentally went to the definition file, and the Firestore is another package. So in this step, we're going to upgrade only Firebase Auth to the modular API to make the app smaller. And we're going to compile the app, we're going to play with the app, and we're going to check the size of the app. Now, there's no required order of upgrade. We don't have to upgrade Firebase Auth first. We are free to upgrade any package in any order. Now, let's go ahead and upgrade Firebase Auth. So in the same file, firebase.ts, let's change the import path for Firebase Auth to point to the modular package just by removing the compat in the import path. And we're going to import functions from the package, which is initialize auth. And browser local persistence. And we're going to use this imported function to initialize auth. So replace the app.auth with initialize auth. And we need to pass app as the first parameter. We need to pass the persistence as an option. Yeah, we want to use browser index local system. Yeah, we want to use IndexedDB local systems. And let's also get rid of the user type alias at the end of the file because we don't need it anymore. Now we're done here. Let's move on to the auth.ts file to update the functions to use the modular API. First of all, let's get rid of the user type alias that we just removed. And we need to import a few functions from the Firebase Auth package to implement the sign in and sign out functionalities for the app. We'll need to import sign in anonymously, sign out, and on auth state change. And we're going to use these functions to implement the functionalities here. Sign in anonymously, and we need to pass the Firebase Auth instance as the first argument to it. And similarly, we will do the same to sign out, as well as on auth state change. We also need to import the user type. Let's do that. Let's re-export it. Now, you probably have noticed a pattern here. Instead of calling the methods on the Firebase Auth object like we did before, we are calling the imported functions directly and pass the Firebase Auth instance as the first argument to them. This is the pattern you're going to see repeatedly in version 9 code, and this is what makes our SDK modular and tree shakeable. Now we're done. We have upgraded Firebase Auth to the modular API, and we are ready to rebuild the app and check the size of the app. Going back to the terminal, and we're going to run npm run build again. Let's go to the browser and refresh the page. And once again, let's do the manual integration test to make sure everything still works. Yeah, the integration test has passed. Now let's check the size of the app. So in the table below, let's scroll up and look for the size. Look for the script main.js, and go to the size column here. And now it's 103 and 350. So let's remember those two numbers and put them into the table we prepared earlier. 103 and 350. 103 and 350. And let's give it a name, which is auth upgraded. So a second. Yeah. Now let's compare with the original size. we have reduced the bundle size by about 100 kilobytes by only changing a couple lines of code. I think it's a pretty good result given the amount of effort we have put into the upgrade so far. And keep in mind that we're still using Compat packages for Firestore and the Firebase app. And the Firebase Auth, which we just upgraded to the Modular API, works with them seamlessly. In version 9, Compat packages and the Modular packages are designed to work seamlessly together to enable the incremental upgrade experience. And when an app uses both Compat packages and Modular packages at the same time in the app, we say that the app is in the interrupt mode. Now, let's keep going and upgrade Firebase app and the Firestore to the Modular API to complete the upgrade process. Let's go back to the IDE. And open Firebase.ts. We're going to change the import path for Firebase app and the Firestore to the Modular API and import functions from them to initialize app and Firestore respectively. We're just going to remove the Compat, import initialize app from Firebase app, and for Firestore, we're going to import the function get Firestore. And we're going to use these two functions to do the initialization. And let's get rid of the 3 type aliases at the end of the file. Now we're ready to move to another file, services.ts, which we have the services implementation for the application. Let's update the services in this file to use the Modular API. And first of all, let's get rid of the 3 type aliases we just removed. And we're going to import a bunch of the functions that we're going to use from the Modular API to implement the services. I'm going to copy the imports from the code lab. Open the code lab, and we are going to step 6 of the code lab. We're currently on step 6 of the code lab. And scroll down to the update import section. We're going to copy this import block. To the top of the file. Now, we have a bunch of error in this file. That's because we haven't changed the code to the Modular API. And we're going to address the issue one by one from top to bottom. So let's start with the search function. So the first thing we're going to do here is to create a collection reference to a collection in Firestore. And in version 9, we use the function collection. And we need to pass Firestore instance as the first parameter to the function. Remember that when we upgraded Firebase Auth, we passed the Firebase Auth instance to the Firebase Auth functions. And here is the same pattern. We pass the Firestore instance to the Firestore functions. And you're going to see this pattern a lot in version 9 code. And next, we need to get the documents from this collection. So we use the function getDocs. And we need to pass the collection reference to the function so it knows which collection to get the docs from. Cool. And similarly, we're going to update add to watch list and delete from watch list. And here, the difference is we are creating a document reference instead of a collection reference. And to do that in version 9, we use the function doc. We need to pass Firestore instance as the first argument, then the path to the document. So this is basically a document reference to users watch list because this function is add to watch list, add a stock to the watch list. And once we have the reference to users watch list, we need to add one stock to the watch list. We use the function setDoc. We need to pass the document reference as the first argument so it knows which document to update. Now we can get rid of the namespace here because array union is now an imported function. As we can see at the top of the file, array union is an imported function now. And we would do the same thing for delete from watchlist, which we use to delete a stock from the watchlist. And the first step is create a document reference to users watchlist, which we have done before. So I'm just going to copy the code from above to here. And once again, we are using the function setDoc to update this document and pass the document reference as the first argument to it. And we can get rid of this namespace because array remove is also an imported function, as we can see here. Moving on to subscribe to ticket changes. We are almost there. So this function is what we use to subscribe to real-time price updates. And to do that, we will need to get a reference to users watch list first, which we have done before. So I'm going to copy the code once again to here. And we need to listen to the changes in users watch list because every time if there's a change in users watch list, we want to get the latest stocks in users watch list, then subscribe to price updates for those stocks. And to do that, we use the function snapshot. And we need to pass the document reference as the first argument to onSnapshot. Cool. Now, in the callback of the onSnapshot, we will get a list of stocks from the users watch list. And we need to subscribe to their price updates. And to do that, we need to create a query, as we see here. And this is how you create a query in version 8 of the Firebase JS SDK. So let's see how we create a query in version 9. I'm going to go back to the code lab and copy the code. Let's scroll down to update subscribe to ticker changes section here. And go to the second snippet where you see there's a price query. Let's copy that into the file. Let's replace this one with a new version 9 version. Now, let's pay a close look at how we compose a query in version 9. First of all, we use the query function, then pass a collection reference to the query as the first argument. And this collection is what we are querying against. Then we create a where constraint here by calling the where function. You can create different kinds of constraints by calling different functions. For example, if you want to limit the number of results you receive for this query, you can use the limit constraint by calling the limit function. And we need to import the limit function. So if we scroll up, so you need to limit, we will import the limit function and call the limit function here and pass the limit you want to impose. You want to limit the query to the number of results. And since we don't want to limit the number of results we get, we will get rid of this. We will also remove the import here. So this pattern, let me go back to where we were here. Yeah. So this pattern ensures that the constraint implementations that we don't use will not be included in our app, right? Because we don't include those functions, we don't import those functions. So they will not be included in our app. Now we have the query. We want to listen to the real updates of the query, which is the price updates. And once again, we use the function snapshot. We will pass the query as the first parameter to it. And that's it. We have upgraded the function subscribe to ticker changes. The last function we need to update is subscribe to all ticker changes. It's similar to the last function, but it is for when there's no user logged in. So we get every stocks available in our little sample app and get their price updates. So I'm going to copy the code from Colab directly. Yeah, let's go to the Colab, scroll down to update subscribe to all ticker changes. And we're going to copy the entire function here and replace the existing one here. And since it's very similar to the last one, I'm not going to go over this function again. Okay, there's no error anymore in this file. That means we're ready to rebuild the app and play with the app and check the size of the app. Go back to the terminal, and we're going to run the command npm run build again. Now, let's move to the browser. And refresh the browser. And let's play with the app to make sure everything still works, nothing breaks. Oh, I already have added that one, so let me add another one. Oh, I added that one too. Do something. Yeah, everything seems to still work. Now, let's check the size of the app. Up here, and look for the main.js again. And we're going to move over to the size column. And now it's 74.8 and 245. Let's put them into the table. 74.8. 74.8 and number 245. 245. Let's give it a name. Everything rated. Now let's compare to the original size again. We have reduced the bundle size by over 200 kilobytes. And now we have an app that's 50% smaller with the same functionalities. It should translate to a faster page load and a happier user of our little app. So it's pretty great. Let me go back to the app. Cool. So if you got stuck anywhere in this workshop so far and want to see the finished code at this moment, you can check out our modular branch directly. I show you the command here. It's available at the top of step 6 of the Colab. So here. So if you just want to jump to the finished code at this moment, you can check out the modular branch directly here. Let's go back to the app. All right, so now the app has fully upgraded to the modular API, and we have reduced the bundle size by about 50%, which is pretty great already. But can we optimize it even more? Well, yes. Let's take a moment to think about what we need to know to do the initial page rendering. And by the way, initial page rendering, the performance of initial page rendering is what we are optimizing for ultimately. So what we need to know to do the initial page rendering? We need to know whether a user is logged in, so we can show the correct page, whether we want to show your personal watch list or the generic landing page. We also need to know the prices of the stocks at the moment, right? And in case a user is logged in, we need to show the price. We need to know the prices of the stocks in the user's watch list. So we can show the table with the content, not just the loading bars. But we don't need real-time updates, right? Because it's only for the initial page rendering. So if we can build a bundle without real-time streaming, and by the way, real-time streaming, the implementation for real-time streaming is fairly large. Then if we can exclude that implementation, then we could build a bundle that's much smaller. So the app should load much faster. But how do we do that? And the answer is the Firestore Lite package. Firestore Lite package is a new package introduced in version 9. It is a lightweight implementation of Firestore. It doesn't support advanced features like streaming, caching, and offline persistence, but it's very small, it's very light, and that's perfect for our use case, where we only want to get the data once. We don't need real-time streaming. We only want to get data once and show the data for the initial page rendering. And we want it to be really small and really fast. So, but eventually, we still want real-time streaming of the prices, right? Otherwise, our app is useless. So we still need the main Firestore SDK to provide real-time streaming, but we can load it asynchronously after the initial page rendering. So that's the idea. Let's try to implement it. Go back to our IDE. So the first thing we need to do is to create a new file and move the real-time services to that new file. So that new file can be dynamically loaded after the initial page rendering. We're going to see how that works exactly, and we're going to talk more about that later. But for now, let's just create a new file and move the real-time services to that new file. So in the source folder, I'm going to create a file named services.realtime.ts. And the two functions we're going to move there is in the services.ts file, which are the two subscribe functions here and here. So the two subscribe functions. We're going to copy them, remove them from this file, and we're going to put them into this new file. Now we need to import the functions used by these two functions in this file. And I'm going to do that by copying the code from CodeLab. Let's go to the CodeLab. And we are on step 7 now. I'm going to click on step 7. Let's scroll down to the first snippet, and we're going to copy this entire import block here. Let's go back here and copy the code, import to the top of the file. Now, everything seems to work except for there's error for Firestore. It says can't find name Firestore. So let's create a Firestore instance here. Using get Firestore. Now, you might have a question. Why can't we use the Firestore instance that we created in another file, which is in the Firebase.ts file? So see here, we have a Firestore instance here. Why can't we use this one instead of creating another one? And that's because we are going to change this Firestore instance to a Firestore Lite instance by just changing the input path to Firestore Lite. And remember that the Firestore Lite doesn't support real-time functionalities. So we can't use Firestore Lite instance to implement the real-time services. Therefore, we have to create a Firestore instance from the main Firestore SDK, like we did here. So this is from the main Firestore SDK. We get Firestore, and we're creating a Firestore instance from the main Firestore SDK. Now, we need to get rid of this first load variable. It does some performance monitoring, which we don't need anymore. So let's just get rid of the first load function, the first load variable, and the if block functions. Cool. Now we are moving to services.ts. And we're going to change to use Firestore Lite to implement the functions in this file. It's pretty simple. We just need to change the import path like this. And let's remove snapshot because we don't need a snapshot here, and Firestore Lite doesn't support on snapshot. Now you will notice that we don't have to make any change in this file after switching to the Firestore Lite. There's no errors in this file. And that's because Firestore Lite implements the same API as Firestore. It doesn't have the advanced features like I mentioned before, like real-time streaming, which is the on-snapshot function, caching, and offline persistence. But it implements the same API as Firestore. So you don't have to relearn a whole new API just to use Firestore Lite. Now, we do have to create 3 new functions to fetch data for the initial page rendering. And I'm going to copy the code from the CodeLab. So let's move to the CodeLab. And scroll down to a little bit to use Firestore Lite to fetch data. And in the step 3 here, let's copy the entire snippet. Let's move to our ID and copy the code to the top of the file. Now we need to import get doc, so let's do that. So very briefly, what these 3 functions do. So get tickers takes a user and returns the stocks in the user's watch list. And get ticker changes function will get the current price for those tickers, for those stocks in the user's watch list. And get all ticker changes is used when there's no users logged in, and it gets the price and the tickers for every stocks available in our little app. Now we have all the ingredients to complete this step, and we just need to use them to do the initial page rendering. Then after the initial page rendering, dynamically load the real-time services to subscribe to real-time updates. And I'm going to show you how to do that. We're going to move to the file main.ts. And first of all, we need to update the import statements. Let's go back to the code lab to copy the code. Scroll down to tie them all together section here in step 7. And let's copy this entire import block back here. Copy here. Now, let's try to do the initial page rendering. And we're going back to the code lab to copy the code. Let's scroll down to step 5 here. So I'm jumping a little bit here because I think it makes more sense for this workshop. And find this block, which has a comment, get data once if real-time services haven't been loaded. So let's copy this block. Let's go back to the IDE and move to this if block, and after this show loading screen block. So over here, let's copy the code here. And we need to change the function to a async function so we can use the await syntax in the function body. So let's take a look what the block do. So it says that if real-time services are not loaded, which means it's the initial page rendering, then we're going to use the new functions we just defined that uses Firestore Lite to retrieve the stock watch list from the user, and we're going to get the prices for those stocks. Then we're going to use this data to render the user page, which is the initial page rendering. Pretty simple, right? Now, here's the interesting part. After the initial page rendering, we need to subscribe to real-time updates. How do we do that? We're going to use dynamic import, and I'm going to show you how to do that. Let's go back to the code lab to copy some code. And we're going back up a little bit to step 3. Step 3 within the tie them all together section. Let's copy this code. Go back to the IDE and put them to the top of the file. And this line is the dynamic import. If you're not familiar with dynamic import, it's basically a way to asynchronously load additional code to your app. And it takes a file name as a parameter, which is the services.realtime in our case, which is the new file we created earlier. And since dynamic import is asynchronous, it returns a promise. See here, it's a promise. And once the promise resolves, the functionalities defined in this file becomes available for us to use. And that's how we subscribe to real-time updates. So let's do that. Let's move in back to the if block, and after the initial page rendering, let's wait for this promise. Load real-time services. Real-time services. We say then this. And here, see that when the promise resolves, the two exported functions from that file becomes available to use. And we're going to use the subscribe to ticker changes function. And within the callback, we're going to subscribe to real-time updates. And this is how we subscribe to real-time updates asynchronously after the initial page rendering. We're almost done. We need to update the else block. And it's basically the same thing as the if block, but this is for when there's no users logged in. So I'm just going to copy the code from the code lab. And let's go to the last snippet. Here, and let's copy the entire thing. I'm missing a, oh. More. It's hard to get brackets to work correctly. Yeah. There we go. Okay, so we're ready to rebuild the app and check the size of the app again. Let's do npm run build. And let's move to the browser and refresh the page. And let's do the manual test once more to make sure nothing breaks. I did that one before. And let's remove something. Yeah, everything works. And we are still getting real-time updates, as you can see on the screen. Right? We're still getting real-time updates. So everything works. Now, the exciting parts. Let's check the size of our app again, one more time. Main.js, and let's go to the size column and look for the size. So now it's 35.2 and 118. So let's put them down in the table. 35.2 and 118. This is using Firestore Lite for initial page rendering. Yep. So let's compare with original size once more. It's about 75% smaller. I have done the math, so I know it's 75% smaller. Only a fraction of the original size of the app with the same functionalities. And it's pretty awesome, I think. All right. Now we have covered everything in this workshop. If you didn't finish, don't worry. The code lab is available online, so you can do it anytime at your convenience. And there's some useful resources linked at the end of the code lab. So let me show you here in the step 7. At the end of the step 7, there's some useful resources to help you to upgrade to version 9. Feel free to take a look. So thank you very much for joining this workshop with me today. I hope you find it informative and helpful. Happy tree shaking. Thank you very much.